Hey y'all, we finished up this house for the rough end, which means we've got the air handler set, all the electrical pulled for high voltage and low voltage, which is the power that supplies the units, which is high voltage, and the low voltage is the control, which is what you know as a thermostat, and all the things that go along with that. I lost the SD card, or I haven't found it yet, that contains a lot of how the ductwork was put together, but I'll show you what we've got so far. We've got this air handler here for the upstairs, the drain pan, which is this part here that it sits in. That's there in case the drain, which is in here where the coil is. There's a drain pan on the bottom that covers the whole bottom of this unit down here. And this drain here looks a lot like this pipe, but we have to insulate it so it doesn't sweat or have condensation form. And that drains all the way under the ductwork on that unit and down the wall and outside. I'll show you more on that later. But we got this drain here, goes out. I forgot why I was showing you this, but you got, oh yeah, we put the drains in, duh. And then you got the code here, and the municipality we're in is this pan has to be drained outside as well. So it runs out, but the way we install our equipment, water should never hit this drain. So we've got a float switch here, which I'm not gonna take that out. I'll show you on the other unit what that looks like. But there's a float in here, and there we go, there's a better angle. There's a float in there, and if this pipe fills up with water because of this drain being clogged, it floats, and the way we wire it up, it makes the thermostat go blank, so the homeowner knows immediately they have a problem. And then we also put a wet switch in the pan, so if this thing even gets moist, it turns the unit off. So they immediately know they have a problem. So water should never get in this backup drain, but the municipality we're in requires that the pan be drained outside. And the reason I don't like that is because where this comes out is probably, I can fit my finger, my index finger, all the way under this outlet. Can't really see real well, but my finger goes all the way under that. So this pan would have to get about 1 inch of water in it before water would even drain outside. And then the homeowner or the business owner would have to notice that there's water coming out of that pipe, and then understand that that is a problem before we even get a phone call. So the inspector was just out here and told me that this trap did not meet code. So we had what he referred to as a running trap, which is this right here. And I'm not sure why we use this here, but that's not acceptable anymore. So I have to build a 2-inch trap. I was waiting on this to dry, so I'll rotate this down, and then I'll go ahead and just show you that. This will be something you guys can see. So what this does is prevents, well, let me rephrase that. When this unit produces condensate when it's cooling, it drains through this pipe. And what happens when we create this trap here is there's constantly water in this trap. It'll make more sense once I get it done, but that prevents the unit from pulling air through this drain from outside. And what happens if you're pulling air through this pipe from outside is it doesn't drain, and therefore it trips this float switch. Let me show you what that float looks like now. If I can get it out. So yeah, oh, good thing we took that apart. So this thing came apart, pretty easy to put back together. But anyway, so this sits down in the drain, this floats like so, and when it's up, It breaks the continuity on the circuit, so it doesn't allow electricity to pass through the switch. And it makes, the way we wire it up, it makes the thermostat go blank. So the homeowner knows immediately that there is a problem. Pretty sure I'm gonna need another 90. So yeah. So yeah, needs to come up a little higher though. So we want to make sure that this level, the top of this pipe, is lower than the bottom of this one. So now I'll have to go and get a coupling. Right. So I got my couplings. And again, the reason we're doing this is the inspector was just out. Basically said that that running trap that we had on this was not acceptable. So we have replaced that with a P-trap. And that was the last one of those I had on our install trailer, so that explains why I used it. But I was not aware that it was a code violation. And this drain line has to be insulated. So the reason for that, even though this is an encapsulated attic, it doesn't matter. As far as the inspection goes, it keeps condensation from forming on the drain line and dripping onto building surfaces such as ceilings, sheetrock, floors, attic space. Especially in these traps. That's usually where we see the most of it. Usually where there's going to be a lot of standing water. And now that's insulated. Looked a little better the way it was as far as the insulation goes. But now that drain's done. I'll give you a little overview of everything that's happened since SD card before. Another thing, this is our fresh air intake. It's going into this unit. We're filtering the air at the unit. So there'll be a filter put in here. That fresh air duct goes outside. We've got to put either a manual or an automatic damper in here, which we'll do at a later time. Just have to have it done before they move in. But we've got this duct here coming over to a distribution box to feed the master bedroom and the kitchen. This is a return line coming off of the return plenum, going into a little hallway right here, just off the master bedroom. And then we've got two returns for this downstairs unit. And we're very limited on where we could put these. So they were put in the living room, and again, we're going to filter that air at the unit, so we don't have to get up on ladders to change filters. And then we've got the supply plenum going up, and that's the downstairs unit, so we've got it going up there. And then this section right here is feeding the downstairs below the area I'm walking on here. And then this upstairs unit, we've got a return here. You can see that line coming down. And you got the supply going up. Again, this is for the upstairs. So that's feeding all of this area, this vent in here. This is a bathroom, bedroom. You got the upstairs and the downstairs trunk lines coming overhead. This is actually part of the downstairs unit because it's feeding the foyer. And we've got this room, this bathroom, and then this bedroom are all part of the upstairs system. And we've got the other return for the upstairs here. So you can see that line kind of going across, the bigger one there on the bottom, all the way over to the air handler. And then we've got a box here for this side of the house. And go back over here and show you some more of what was done since the last time we were here. So from the main panel, electrical panel, where the electricians are working, we've brought the wire up and into this. This is all they had, was this exterior style panel. Usually on the inside you don't have a cover and it's not waterproof, but this is just what they had. We got a 60 amp breaker for each, indicating an arrow indicating which breaker is controlling which unit. All the wiring stapled in, coming in. We've got the thermostat wire for the indoor, or excuse me, the thermostat coming in here, going to the outdoor unit, the safety switch wiring. This is a surge protector that's wired in, and the thermostat for the downstairs, I'll show you when we get down there, but that wire is stapled up here. It runs across and down. We try to keep this attic space good and open so they can use it for storage. Got everything up, overhead out of the way, all the wiring out of the way. The only thing that was really sort of not where I would like it was this, but it's just too much to try and get a slope. The drain has to constantly slope downhill so the water will run out, and we don't have a spot where it builds up other than the traps. So running a straight line out was the best way to do this. And then we've got the same hookup here coming off of that same electrical panel over there. We've got the high voltage coming in on the bottom down here. The thermostat wires coming in here, surge protector. And then something else with the drain here. We put these in so we can take this cap off and pour our cleaning solution down through there to kind of flush the drain pan out. And then if we just want to flush the drain line, we can take the top of the float switch out here and clean the line that way. And then for code, you have to be able to flush the drain line without cutting it. So this contraption goes down in when you take the float switch out, makes a seal, so it goes down in, and then you can pressurize it through here. Right, so also didn't cover the copper line. So the refrigerant has to flow from the outside unit to the inside unit. The liquid line here doesn't have to be insulated, but the mini split lines were all they had at the time I ordered this. That's why this one's insulated. But that copper runs up and over and downstairs. Same thing with this one, up and over, downstairs. And the thermostat for the upstairs, so that line is coming out. You can see it stapled right here. It's fastened to the wall here, runs up all the way over. So when we come back here to set the condensers and start the unit up, all you'll see is sheetrock here with this wire sticking out, hopefully. If not, we'll have to locate the wire. Let's head downstairs. So, this was a unique build. We had to do some things that we don't normally do. I'm not a big fan of air distribution or spider system ductwork, but for the downstairs trunk, so the air handler that's all the way over at the far end of the house, we had to run that trunk up and over, and then there's a flex line that runs from that trunk to this box. And then we had to basically treat this box like a trunk line, because there's no way to get the ductwork into this area, because the bedroom, this is basically the same floor plan on top of us here that we have downstairs. So this is all floor space above us. So in the closet upstairs, it looks just like this. They're just gonna cover this because there's a duct, that one up there, coming down through the closet. And then we've got the takeoff that I think there's some in the videos there that these lines are attached to. You can see that black or dark liner in there, so that's affixed to a round takeoff in this box or in the trunk lines, and then we pull the insulation down snug to the box or the boot, as we call it. And then we pull the silver liner over that and kind of tuck it in so the insulation is not poking out. And we either use a duct tie, tape, or mastic to seal that. And the code official just told me that we need to tape from now on, which we typically do. But we did the duct ties here. And then they're going to bring the ceiling down in this closet so you can't see this ductwork. So instead of it being up there originally where you see these floor joists or ceiling joists, depending on which floor you're on, the sheetrock would typically be fastened there, but they're going to frame out a new ceiling joist under all of this ductwork to sheetrock to conceal that ductwork. So these, I had to pick up a new battery. So for the downstairs, again, that unit that's all the way over in the corner up here, back there, this vent, that vent are both coming off of that trunk line up there. It's the trunk that's on the bottom, so they kind of run together. The upstairs is on top of the trunk. I don't know how well you can make that out. And then we've got this vent and this vent. And being we had limited space for return placement, these two returns going for the downstairs unit, again, way over there that I showed you upstairs. That's what they look like downstairs. And when we come back, this will be sheetrocked. You'll just see the metal boxes and the openings of the vents, and we'll cover those with grills and registers, what you typically see in your house. Here's another one we had to bring through a closet wall. This is the dining room. So that vent's coming down through a closet, or that duct's coming down through a closet, running over to this. We had to get some non-insulated boots and fabricate sort of our own deal in some of these. We had to cut them, make them shorter from, you know, the way we're looking at them top to bottom, so that they would fit in the floor space. We don't have a problem over here, but these are all running off of that unit, same unit for the downstairs. This is kitchen. Here's one we had to fab. So I think these are 2x8s, and we've got a 6-inch vent here, which is you know, has R8 insulation on it. So technically that should be a 10-inch diameter piece of flex, and I believe this is a 2x8 joist. So that gives you an idea of what we have to work with. But then when we get over here, we've got the breakfast area. This is open above here, so we don't have to worry about that. Same thing, master bedroom. Another air distribution box. There just wasn't a feasible way to get a ductboard trunk back here, so we had to flex over to a box, put the takeoffs in. Here's the return I showed you upstairs. It's close to the master bedroom, and here's where we decided to put the thermostat for the downstairs system. Coming into the bathroom here, this is a toilet room. We've got a vent in here. This is a shower, tub, just, I guess, sort of common area right here. Walk through, we've got a vent there. This is a closet, vent, laundry room, vent, pantry, vent, a half bath for a guest, I assume, vent, and this is kind of just a sort of a mud room, and we just got airflow coming through here. So this place doesn't require a vent. There's not going to be anybody sitting in here. It's just going to be walking through. And here we go. Here's where all the copper for both units comes down through the wall, and the thermostat wiring. So code in our municipality right now is nail guards have to be 2 inches below. I call that a header. I don't know what framers call it. That's just what I call it. So we went a little bit further. So what that's to do is to prevent the sheetrock guys or the molding guys from driving a nail or a screw into that copper line set or wiring. And same thing over here. This is the insulated drains for each unit. And then you can see up there, these are the auxiliary pan drains. They're not required to be insulated. Show you where these come out outside. So this is where the condensers are going to sit. When they get all the prep work done, we'll come out here. This is, I'll go back in and show you how the electricals run, but we'll have another panel here similar to the one upstairs. What I call a split panel. We're just going to take 100 amp wire and split it into, I believe one of these condensers is a 40 amp, one's a 30. So there'll be a 2-pole 40, 2-pole 30, or a 50 and a 30 out here. And the drains will come out, and you'll see the, you know, what they choose to finish the outside wall with. And then we've got the auxiliary drains coming out here, which should never have water coming out of them the way we do it. And this is the fresh air intake. So I like to let it hang so that the guys that put up the soffit have to do a lot of extra work to shove it up in the attic and cover it up. So I'm hoping that they will cut a hole and pull this through, so I can just come back and cut that flush and affix the louver grill to their soffit for this fresh air intake. And now let me show you the electrical wiring, and that'll wrap this up for the rough end. So we've got, typically, I don't know how this is done everywhere else in the country, but what I've always found is the HVAC guys are expected to pull their own high voltage wire, even though that's an electrical thing. So we've always done it. So we've got one of these wires, 100 amp wire going upstairs for both air handlers. The air handlers are going to pull 40 amps each. I believe they're fused at 50. Have to double check that. But anyway, we pulled the wire the way the electricians want it. We've got a wire going upstairs for the air handlers, one going outside for the condensers. We left them plenty of slack so they can put it in whichever panel they want. And they asked that we supply our own breakers. So we've put our 100 amp breakers in there. This is one of the rare cases where they want us to pull our wire from the indoor panels. Typically we have to pull it from what we call the meter can, which is where your power meter is, and then you'll have a couple of slots for breakers outside. But this wire runs up in between the first floor and the second floor. That's our two wires there. So our two wires there, and then they come out here. And I didn't have any nails big enough, so we just hammered, excuse me, I didn't have any staples big enough, so we just used nails to hold them in. And that's where the wire goes through the attic floor, or first floor, the subfloor for the second floor, up to that panel. And then this is the wire going outside for the outdoor units, and it goes out right there. So that is our rough end for this house. The code official went ahead and passed our rough end here, because I met him here and made sure everything that he wanted was done. I had to hang some duct up to meet his requirements, and then put in that P-trap, and then we got to do a damper on the fresh air intake. So we're all set. Yep, and that's where he gave us a pass on our rough end. So it'll probably be 6-7 months before we're back out here estimating to do the condenser set. So subscribe, and if you're interested in this kind of stuff, and you'll get a notification when the rough end on this is complete. It'll be part of the series that these videos are in. Anyway, thanks for tuning in. Catch you next time.